Good afternoon to our next webinar about JovianDSS. We have already few recorded webinars, but we are missing just evaluation guide and kind of quick start. So first steps with DSS, with JovianDSS. So we will talk about this today for these people which have no idea how to start and how to evaluate JovianDSS. So our agenda for today is I will introduce the demonstration environment and the environment which you can also use on your site. Okay, then I will show how to download and how to install Jovian as a virtual storage appliance, because as a bare metal will also show how to do it. But of course that will be very difficult to demonstrate on the bare metal. Okay, so we will get the trial key, we will put the we will install Jovian, we will create a pool, we will also discuss about best practices, how to create the pool, how to get the best performance, and we will explain some details about cache, connecting iSCSI, if we have enough time, also NFS Share. And also we are going to show, let's say, auto snapshots if we have enough time. Okay. So our demonstration environment, I will not demonstrate the whole cluster today. We will just use a VMware as a VMware S6 as a base machine, and on this machine we will run JovianDSS, or we'll install JovianDSS. As I mentioned, installing on the bare metal is a bit different, actually very similar, but we need to prepare a boot media, and then I will maybe switch to the web. So you need to go to our web first, and you can go to downloads, or you can just go to the partner site. I am already logged in. If you have no login, you can create one. In downloads, you have the DSS JovianDSS trial, and of course you can download the latest ISO file here, right? You can also download the quick start, which is showing the first step. Okay. But when you will need the trial key, so you will need to log into our partner portal and get the trial key, right? So that's the my products, JovianDSS trials, right? And you can just click generate a license key and describe system name, let's say node demo 250 customer, and okay, that is the key which I'm going to generate right now. I will use this in the few seconds. Okay. So as I mentioned, we will have the VMware running, and on top on this we will install our Jovian. Okay, so let us switch to before I was downloading the Jovian, and I was putting everything on a USB drive, because you will need ISO file to download and unpack. So I was downloading latest one of the latest ISO from our FTP. That's the build number, right? Okay, if I click, I see some files here inside, and there is a boot directory, very important. So you can sort on type, then you will find the boot inst file. You need to run boot inst once to make your stick bootable. So USB stick, you need to have bootable. So click on right click and select run as administrator, right? You have to select run as an administrator, because otherwise Windows will not allow to change master boot record, and we are going to make the disk bootable, so we will change the master boot record. Okay, the only thing what you need to do, run as administrator directly from the stick, confirm with space, and confirm one more time. At this moment, the master boot record of this USB stick was updated, and the stick is able to boot. Of course, you will need to reject the USB drive to safely remove from your Windows, right? So because otherwise it can be that the data will be not really written on the disk, right? So here you have this command, or you can also use somewhere here. Okay, but there is another very important exe here that's called config. You can just run. You can also run as administrator, doesn't matter. Okay, and in this menu we have option to remove installer or get installer back. So if I click on R, then the software installer was removed, and if I want to get the default situation, I can click on D, and now the software installer will be as a first. So when you want to install on the, let's say, SSD disk in your server, then of course you will use installer from the USB stick. When the stick is starting, it will show you the available disk, and you will select which one, and installation program will move the image on your selected installation disk and make it bootable for you. If you select remove installer, then you will boot directly from the USB stick. So the USB stick will be your boot media. For testing it is okay, but for production we do not recommend run from the USB stick, because USB stick do not have endurance required for the boot media. Boot media endurance is in 5 years that will be about 1 terabyte data written. So the regular SSD disk, kind of consumer disk, has something like, let's say, 50 or 20, 30 terabytes. So it is always enough to run Jovian for more than 5 years, right? Okay, so that was a way how to prepare the boot media, or how to make the installation on the machine, on the bare metal machine. Now we will switch to our demonstration environment. So as I mentioned, I have a 6 running. A very latest version also accept Hyper-V. So I'm running UP13. So the UP13 from our FTP, it's also running under Hyper-V. I was installing on my another notebook Hyper-V, and then installing JovianDSS, and it works perfect. But here we are using a 6.6. I was already installing one machine, but of course I will show how to install new one. So we will use this subdirectory, and I will create new virtual machine, right? So typical or custom actually doesn't matter, because you can change the settings later, but I will select custom, and that's the test. Okay, that's the VM name. I will put in on this data store, which is also created by Jovian. Another Jovian which is running here, local VSA, that's the Jovian which is making the storage here. So I'm selecting Linux and Debian 7 64-bit. Then please select minimum 4 cores. Then please select, let's say, minimum 16 gig. You can also test it with 8 gig or something less. But if you want to make some, more intensive test, then I think do not try below, let's say, 12 giga. production system supposed to run with, let's say, minimum 32 giga. You can try to put less memory, but actually it's doesn't make sense because the memory is very good utilized for the read cache. That's why today cost of the memory is not so huge, but the advantage of using more memory is very big. That's why we are always recommending to run at least 32 giga in production. Okay, let us go to the next. For the cluster you will need more interfaces, but for just a single node and the demonstration, one interface is enough. Parallel driver, of course, is the best, paravirtual driver. And now we need to create a disk for the boot media. In my testing, I will create my machine disks as also 16 giga. So to recognize the difference, I will put 15.9, and that's the minimum size which is accepted as a boot media for the Jovian. And also I'm selecting thick. It means initializing the boot media. This is also recommended. So now the boot disk is initialized, so it's fully written with zeros probably. Fully the space is reserved. It was fast because recent Jovian, which is providing the storage here, that's the Jovian which is providing storage here, supports VAI, so the initializing this is also accelerated. Okay, so now we have just created Jovian, so we go to edit settings. We need, of course, some more disks, so maybe I will select add hard disk, create, and as I mentioned, I will use just 16, so just confirm, add hard disk, and just with enter confirm all defaults. So now I have the 2 hard disk. Maybe later we'll create more. Okay, so we are ready to boot, but if I will boot right now, that will be no boot media, because in the CD there is no boot media so far. So we need to select CD and select the ISO file, which I was downloading already here. I will use also this build UP13. Okay. The latest official is UP12, but I hope still this week or latest next week we will release officially UP13. Okay, so now we have the ISO file, so we can start on the fresh installed virtual machine. So the power on is done, so now we can go to console. Okay, so as I mentioned, launch software installer is default. Okay, this is a small problem with the console on version 6 in VMware, that sometimes you will see the problem. In such case, just close the console and reopen one more time until the bug is fixed. Okay, so we are now starting the Jovian installer, and the installer will show us all available disks after confirming the license. Okay, so as I mentioned, the 15.9 is a disk which, let's say, I was putting such a size to recognize my other disks. Of course, in production you will have a bigger disks, but now when we are testing, I just confirm default, so all the disks are 16. In order to recognize which disk is a boot disk, it's a nice practice to put 15.9, which is the minimum size. maybe you need to later reinstall Jovian, then you know which disk is used for the boot media, and because maybe other disks are used already for the pool, for the storage. Okay, so I'm selecting this disk. Now installer will move the image on the boot media and make it bootable. That's it. And after we will reboot, and we are ready to enter the product key to go into the web GUI. Okay, so now it's copying files. Checking file consistency. And we can reboot. So now I just press enter to reboot. After rebooting, a system will start with factory default, so we will need to enter a wish IP address. Okay, close, reopen. Okay, it's loading. So now by meantime I will go to our web, and I have just the new key. I need to copy this key. Okay. Okay, so now Jovian must be starting already from the disk, so it will be not running installer but starting from the disk. If you want to make sure that it is not starting from the ISO file, you can go to edit and select CD and just select default client device, so the ISO file will be deactivated. Okay, so now system is already started with factory defaults IP, so 192.168.0.220. Of course, we can change it. If you press F1, then you have all hotkey which are available here. So Control Alt N, like network, is for changing, editing network settings. So I will just press Control Alt N. Then I want to change the IP. I want 250 in my network, gateway 192.168.0.1. Apply. So after adding the IP, which IP I can already go to the GUI. So now I will select click on advanced, add exception, confirm. So that's the node ID, host ID, which is shown here. And of course we need the product key. So I have a copy the trial key from my web, add, run. Okay, so now password admin, and just accept the license, and we are in. And first surprise, we have 2 disks, but we don't see a disk so far. So there is a description in the help, in the release notes. When you are running system as a virtual machine, as a guest, so under Hyper-V, UP12 doesn't work, but we will update this. In UP13, Hyper-V is supported as well. You don't need to change any settings, just works. In ESX, you need to add such a setting into system settings. So copy, because VMware default settings from the virtual machine running under VMware does not recognize disk UID. Is just naming disk with the regular naming like SDA, SDB, but not by ID. So in order to enable this, we need to change the settings of the virtual machine. The virtual machine must be shut down. So I can go here and click on Ctrl Alt K and the shutdown, or just power off on the from the L6 GUI. Okay, so after shutting down, I can edit these settings, because if the machine is running, you are not able to edit these settings. Okay, so now you go to configuration parameters, add row, and that's the disk dot enable UID is equal true. Okay, so now we have option for disk by ID enabled, and we can boot the machine again. You see it's launch system only, so it's not showing installer. If this happens, you need to just close and reopen. Okay, add some more disk into this virtual machine. So I will just click add hard disk. One more, because we will need some more disk. Okay, let us okay, and now it's better. All the disks which we were adding by meantime are already here. So now I have disk 1, 2, 3 till 8 disks. Of course, if you add the disk right now from the ten, 11, 12. Okay, we have enough disk. So you see, now we have 8 disks. When I confirm, then we'll have more disks. Sometimes you need to refresh the screen. Sometimes the disks are appearing automatically. If something happened that you will not see the disks, you need to refresh the web browser. Okay, we have 12 disks, so it's quite nice config. We can make a pool already, but yeah, before making the pool, let us see the system settings. Okay, network. We have set the IP address for the gateway. Okay, that's 192.168.0.1. So we have the gateway IP, but the default gateway is not selected yet. So we need to change and select default gateway. So now default gateway is selected. Next one is server name. So I will put DSS 250. Okay, the host name I will also put node, let's say 250. It must be unique name in your network. Okay, so we have plenty hosts. Maybe leave some extra random number here. If you don't have so many, you can put a very simple name. Okay, DNS 192.168.0.1 in my network, and I can apply. Now I can test whether everything is working well with network. Very easy. Go to system, change from NTP server from manual to continuous, and apply. If it will work, so it will not prompt with error, then it means your network settings is working properly. So that's the case, because it is using no IP but the name, so the DNS server must work properly, and of course gateway must work properly, otherwise you will see the error here, right? So next tab is here system settings. So every reboot, you see we were just rebooting, the settings is saved, but when you click on this button you can also save the setting manually. Also you can, using options, you can download these settings which you have saved to your desktop. So I'm download, so I have these settings, and I have these settings on my disk. Okay. In the update you can update to the new version, so you can upload, browse and update the new ISO file here. So for updating you are using ISO file, exactly the same file as you are using for installing. Okay. Now we need to go to administration, and sometimes you will need to go to console. So in case of VMware it is very easy. You have the console just directly from the VMware. Okay. It was not refreshed, so I was pressing F5 button now. So you can go to console here and use some, let's say Ctrl-Alt-T like tools, and the ping I can enter 192.168.0.1. That's my gateway, and I can check also here using ping whether my network settings is working properly. Right? Okay. But there is also option to go to the console via PuTTY. So we just need to enable this. So there is a remote console access. So I can just click on enable, enter the password. So I just enter admin, apply. Okay, well, then you go to PuTTY, and then you can enter the IP address. I was already inserting this, so you need to enter this IP address of your Jovian, so 192.168.0.250. You need to enter the port. See, it's 5 times 2. That's the default port which is here. Of course, when you put the different port, you need to put the different port here. And in the data, you put the username is admin. In keyboard, you put the VT 100. And when everything is done, you can just put the name of this session and save it. Okay, so now we have to save the session. If you forgot the parameters, how to access this, you can just click on the question mark, and you have also all this explained one more time here. So you don't need to remember really. Okay, so now I will just open, and you see there is also information that admin is the username here. My password was admin as well, so I'm already in my console via PuTTY. I can also go to the Ctrl-Alt, let's say W, and see some settings like kernel module parameters or tuning options. Let's say jumbo frames are here. CPU frequency scaling, but this is not real hardware, so it's not supported here, right? Okay. Kernel modules parameters. So there are some drivers having different parameters. The ZFS module parameters are also listed here. Please do not change these parameters if you don't have any hint from our technical support, or you are expert and you know what you are doing. Okay, so that was access via PuTTY. There is also another way to access system with command line, so CLI, and I will enter also admin as a password. But CLI you will use also for scripting, so you need the key, and when you put the key into the SSH command, then you will not need to enter the password. So I will generate the key, and the key is generating with the host name, so node 250. Okay, I will save this key, then open the container. I will copy these keys or cut and copy to CLI directory. Okay, so I have this key in my CLI directory, but to run SSH under Windows I prefer P-Link. So the PuTTY application, which is nothing else like SSH client, but the P-Link is running very stable on the Windows. Some SSH are not. So I prefer P-Link, but for P-Link you need a private key. So I use a PuTTY again. All this stuff you can download from the PuTTY NL. Okay, so when you go to downloads, then you see you have a PuTTY, you have the PuTTY, and you have a P-Link. All this stuff is here. Okay, so I need to run PuTTY, run, load. I need to select all files, then I can select my node 250 key, confirm, and now save private key, yes. So I will put JDSS 250 and save. Okay, so now I have a private key, so now I can go to the DOS box. I'm already in the CLI directory. Okay, you see this key JDSS 250 is already present, so I can use I can start P-Link, so PL, and tabulator is already completing my command. So -I and J, I will press tab. You see, when I'm pressing the tab, it is finding all the programs with the J. So 250, that's my key. Okay, -L is a username. A username for our CLI access is the CLI. Then the port. If you use SSH, you use a small p for the port. If you use a P-Link, you use capital P. So that's the difference only in the syntax. So 2223, that is the default port. If you notice, I will go here. You see that's the 2223, the port for the CLI access. Again, if you forget something, how to access, click on the help, and you have the explanation here as well. Okay. Okay, so the port and now IP address, so 192.168.0.250. Okay, enter, and that's the commands. If you run this first time, you maybe ask for the confirmation, so you press epsilon key and confirm. So now the commands which we have here, some of them are very useful. For example, this ODPS, the ODPS Offsite Data Protection Service, which can be used for many things. It can be used for the in the UP13 it can be used for the consistent backup, so database consistent backup on the interval and retention basis, and this can be backup between two pools or between two Jovian servers. The second server can be in a local area network or also over internet, because this will be asynchronous data replication. Okay, so in our case we have a very simple system, still no storage, so I will create a pool. So now the settings was done, so we can create a pool. Without pool we cannot use the product, right? So when I select one single disk, okay, there is no other options available. When I select two disks, so I have already option for the group, mirror group, right? If I select three disks, the first Z option is available. So Z1 is a single parity disk. Why we don't call it RAID 5? Because it is similar to RAID 5, but it's not working the same way as the hardware RAID 5 is known. Because hardware RAID 5 is working on blocks, and the Z1 RAID is using data to calculate the parity. So on the very beginning, when there's almost nothing on the disk, we will show that the replacement will take just a second. Okay, so more. Then we have also dual parity is something what we can compare with RAID 6, and one more that will be Z3. We have something what we can compare maybe with RAID 7, which is not existing, but it is exactly 3 disk parity in the group. Okay, we can, let's say, start with mirrors. Mirrors are giving best performance because the system don't need to be busy with calculating parity. Single parity, dual parity, and triple parity require system to calculate the parity. Okay, so now we have single mirror. Let us go to the I can select one more mirror, also edit, but let's say I want to edit later, so I can still remove it. Okay, when I will go, now I'm in the data group tab. When I click next, then I will switch to write log. Write log is something to protect the write cache, which is always in RAM, because RAM is mostly losing the information in case of power failure or some other system failure, hang and so on. So that's why we need a protection mechanism for the write cache. You can compare this protection mechanism to the BBU unit in the hardware RAID controller. Hardware RAID controller has also write cache, write back cache, which is on the local RAM on the card, on the RAID card, and BBU unit is responsible to protect this, right? So here we will be using a fast SSD disk with a very good endurance. Everything what is written to the write log which is on RAM will be also written to the write log on the SSD. And in case of power failure, after rebooting the system will automatically find that this data was not really committed to the pool, and this data which was in RAM and protected in the log will be read from the log and committed, posted to the or saved to the pool. You can use a single disk, of course, but when you use single disk, when this disk is failed, then the logging will be switched to the pool. In this case, you will have a very slow system if you're using a sync, but sync kind of I/O is default. If you switch off the sync, I will show this later, then the logging is not used at all. So if you want to avoid that in case of disk failure the system will be very slow, you need mirror, then one disk failure you will give you the time to replace the disk from the mirror, but the logging, so the protecting will still work. That's the, of course, most recommended log configuration for mission critical system. Okay, so we have the write log. Next step is read cache. Read cache is again always in RAM, but if there is not enough RAM to keep the data which are so-called hot or warm, or data which are frequently used or recently used, need to be in cache, in a read cache. So you can add a SSD disk to expand read cache in RAM to the SSD disk. Of course, my all disks are regular disk, but you will use a SSD disk here. Okay, so that's the read cache, and next step will be spare disk. You don't need to use a spare disk, but you can mark one of the disks as a spare, and this disk will be used for replacement. Cannot be used for some odd, for expanding data group already, right? Okay, so we can add it. Okay, so now we have mirror for the write log. We have one disk for read cache, and we have one disk for spare. Of course, you can add more. You can modify this later on as well. Okay, so now the pool name, pool-0 is very nice name, so I will just confirm it, add the pool. So now we have a pool which consists of one single mirror for the data group. We have a mirror for the write log, logging the cache from which is working in RAM, and on opposite side, on reading cache, we also expand with the one small disk. So that's the pool. When I click here, so I can see how many disks I have in the pool. In the disk groups, I can see what is the structure here. So I have a mirror 0, write logs, which is also mirror 1 in this case, one disk as a read cache, and one disk as a spare, right? If we need to expand the group, if you need more space on the pool, so we can just use add, and we can use add group. Okay, so I can choose add group, and I can select another mirror, add, and of course confirm, and now my pool consists of 2 data groups, right, and one write log. Okay, so now we'll see there is more free space, right? You can add new group any time, but please add always the same kind of group. So when you have mirrors, just add mirrors. You can manipulate with read caches. Let's say you don't like this disk, maybe you will use a different one, or bigger one, or faster one. You can just go and delete. You can do it in production. So the side effect here will be that the data which were in the RAM cache is still caching, but data which was in the SSD cache is no more available, and in such case data which were in SSD cache now need to be read directly from the pool. That's the only what happens here after removing read cache disk, and of course you can go and add another read cache disk again anytime. Now new disk for the read cache is in the system, and there is more space for the read cache data in the system. Same with write log. Write log, let's say I was having mirror, maybe I need shortly to run without mirror, so I can just detach. In mirror we have always option attach and detach, and so go with the redundancy lower or higher. So when I detach, yes. So now instead of having a mirror for log, I have a single disk for log. But I can go, and now detach is no more available, but I can delete the disk. Okay, so deleting write log means now if synchronous I/O is coming, then the logging will be still working, but the logging data will be redirected directly to the pool. So for the logging we need very fast I/O device, and the pool itself is mostly not so fast. 2 mirrors, so that will be I/O equal to disk I/O times 2, right? Because we have 2 groups. So that will be very poor I/O and a very poor random performance. Or you switch your way of the committing from sync to sync disabled, not sync always, and in such case the logging will be ignored, and then your system will be fastest, even faster than with the SSD log. Okay, same thing with spares. If you want to have this disk as a just available disk available for your expanding data groups, you can just delete, and there is no more spare disk marked in the system. All right. So now we have just 2 mirrors. I can even remove this read cache. Okay. So now we are coming to the situation that I have no read cache, no write log, no spare, just 2 groups. Okay. All these disks were removed, and they are shown as a available disk, right? Anytime I can again expand my data group, add 1 more mirror, or anytime I can come back and add my write log, maybe this time only single disk. And again, you can do it in production. You cannot remove the mirror, the groups from the data group. You can only add, right? So in case of caching disks or write log, we are free to reconfigure this in production. In case of data groups, there is no way to remove data groups from the pool. The only way is just backup your data, delete your pool, and recreate the pool new with the new structure. Okay, so that is the pool. Of course, you can have more than one pool in your system. When you just say add, you can create 1 more pool. We can create the pool even with a single disk, right? Add, so next. So my pool will have the now pool 1. 1 single disk is enough to create a pool. But of course, you will not use all advantages which system provides. So all these advantages which we have, which are listed here, like data integrity, data availability, acceleration, optimization, of course, yes, it will work, but plenty of these features will not work with single disk. Okay, so but having single disk, so I have 1 disk, we can fix this problem and change the disk always to mirror or even to triple mirror. As I mentioned already, single and mirrors are due to attach detach. So when I click the button, I can always attach a disk to the single disk, okay? And I can also attach a disk to the mirror group already to make so-called 3-way mirror. So now in my mirror we have 2 disks, but when I click on attach, select 1 more, then my first mirror group is now consists of 3 disks. So the 3 disks are working in the mirror now. And you can attach and detach disks anytime. Of course, attaching disk with data will cost so-called resilvering. Data will need to be mirrored from the running disk on the new disks, right? So we'll see the resilvering starting and copying the data on the new disk. Okay, same stuff on the first group, on the first pool. I have mirrors like this. Just here, when I click attach, I will be changing two-way mirror, so the simple mirror to three-way mirror. Okay, maybe it will be good idea to add already a target, so I can add the new target. So that's the target name. I will put not 250, but like, let's say, webinar. Add, so that's the target. Now there is no zvol. I need a volume for this, so I can add. So now let's say zvol 00, size, let's say, I will say 10 giga, 100 giga, 1000 giga, so 1 terabyte, let's say 10 terabyte. Whoa, that's a lot. In case of my 16 giga disk, right? So, but it works when I select thin provision. I can create, disk which is behaving like 10 terabyte disk, but it's only taking very little space. It's taking space only when the data are written to this disk. So as I mentioned already, the sync parameters is a critical parameter. By default is sync always, means any I/O is treated as a synchronous I/O, means everything must be protected with write logging. If there is no separate log device, so no SSD for write logging, the logging will go to the pool and the system will be extremely slow. So the default sync always means you must have SSD for write log. If you don't have, and you have, let's say, uninterruptible power supply, you can compromise and say disabled, then all the logging will be ignored. There will be no logging. There will be just caching in RAM, and every 5 seconds data from the RAM cache is formed in so-called transaction group, and the transaction group will be written to the pool. Okay, so we select disabled, then the system will be working in the fastest mode, because we'll be ignoring logging. Running this with an uninterruptible power supply is quite okay, especially when you don't have a really mission critical application. Or for the backup disk, we will even recommend to put it on disabled. If the disaster happens, only the last 5 seconds of data will be lost. In case of backup pool, there is no problem, because the backup, let's say, run every 10 minutes or every 15 minutes, every hour, so the 5 seconds doesn't count at all. Okay, so we have a zvol. I will end the target, so I can go to I was putting a different IP here, and maybe that's a good idea, because my IP is 250, but I can maybe even configure a virtual IP and use my single interface and use 255 netmask. That's the, let's say, VIP 251. Okay. I have configured virtual IP. Why? Because maybe I will later on use this system for the cluster. Of course, I will have more IP for the cluster, and on the NIC, which is dedicated for the exporting iSCSI, I will put this virtual IP, and my storage clients will already use IP which is so-called virtual and can be switchable between two cluster nodes. Okay, so now I go to the Maybe I will remove and re-enter this one more time. I can remove this as well. Okay, so discover 192.168.0.251. On 0.250 it is also available. Now the target is here. I just need to connect it, and then go to the disk management, and in the disk management my 10 terabyte disk just show, so I put online, then I initialize the disk, and I can format the disk. Okay, so it was quick that we are able to access the iSCSI disk, just format, and we can start to copy the data on the new created disk. And you see my system has just a few gigabytes, and there is still no data on the system on the iSCSI target, but now we can copy some data. So I go to browser, okay, then maybe select some logs, copy, go to the new created disk, let's say new folder, switch, and copy. Okay, so now I can maybe I have created some data. Okay, maybe make new tst. Okay, now when I copy tst, it will be, sorry, it has already some more data. Okay, so now when I run the scrap, what is doing, scrap will be reading all the data which is on the pool, and in case of finding errors, data will be repaired automatically. So how the system will find errors? Because every data written to the pool is written together with the metadata, so with the checksums, and so we are using 128 kilobyte block size. So every 128 kilobyte block size has a data, so-called data stamp or hash, which is nothing else like working like checksum. And in case of reading, data is always compared with this checksum, and if it doesn't match, so will be taken from the mirror side or from parity, and the bad sector will be already marked as unused, and data will be self-healed, so the data will be again recreated in the new blocks. Okay, so I was mentioning that when I will have the now changing the redundancy, like attaching a disk, oh, I was attaching the single, sorry, so I can attach here also the one more disk. So in the group I have a single, attach a disk, okay, so now you see the resilvering coming because the data need to be copied from the existing disk to the new disk, right? So because we don't have a lot of data, so it is working very fast. Same happens when we replace the disk. Let's say I want to replace this SDI because of some problems. I select new disk to SDM and then apply. So now replacing, you see there is we have replacing, and of course the receiver doing the same stuff. It is very quick because we don't have much data, so the replacing the disk is done. And that's also the good difference, or easy to recognize difference between replacing the disk in the hardware rate controller, which is working on blocks, means all the blocks which are on the disk need to be rebuilded, and in our case the rebuilding process is called resilvering, but it's nothing else, the same stuff, but the resilvering working on the data blocks and rebuilding working on the disk blocks. Okay, so that was the thing with the mirror. So now let's say we want to back up our data, and we want to back up our data from this ZVol to another pool. I didn't install another Jovian, so I can back up the data between two pools. Here we will need to use the CLI, so the CLI from the ODPS, and ODPS I will need to create the task. Normally I will attach the second node, attach backup node, but in our case we don't need to attach because we have a within the same node. So I can do the auto snapshots only on my source, or I can do the backup. So all the options are possible, and the options are described in the help and the offsite data protection service. This service is described here. So it works on the retention plan, so retention interval plan, which is always kind of this kind of plan. It consists of the as many segments as you wish. So now this example is the last 1 hour. The snapshot will be created every 10 minutes and the replication as well. Then for the last 3 days every hour, and for the last month every day. So it's very simple structure of this retention interval. You can add as many as you wish. In our case, when I will put ODPS, let's say set for the settings, then I see I have no backup nodes attached. The default retention plan, the factory default retention plan is for the last hour every 10 minutes snapshot, for the last 3 days every hour, and for the last month every day. But of course we can use different plan. So when I use ODPS create task source is equal to pool and the plan let's say 10 minutes every 1 minute. In such case pool 0 doesn't exist, of course. Okay, so in such case I didn't put any destination, so I will put set. The set will tell me what I have. So I have no backup node attached. The default is as it was, because I didn't change the default. I was only creating the task which has a source as a pool 0, and there is no destination, and there are only a retention plan. In such case I don't make a really backup. I will just make so-called auto snapshots. So on my source the first snapshot is made already, and on my destination I have just single disk. I don't have even ZVol. If I want to copy this data to another pool, I will need to create zvol but not target. So just create zvol. I can put the zvol with exactly the same name because it is on the different pool, 10 gig, 100 gig, 1000 gig, 10,000 gig, and also thin provision. And for the backup, you always create with disable sync. You don't need to really sync data for the backup. Okay, so add. Now I have a destination zvol, so I will be having option to replicate this data from my production pool to my pool 1, which is a let's say backup pool, right? So we can redesign this task, so I can just go and delete. So when I click on ODPS, I always have the help, so I can delete the task and recreate this one more time. Okay, so delete the task is delete task and the pool, pool 0 zvol 00. Okay, task is deleted, so now I can put on set. There is only default plan but no task, so I can recreate. So create the task, my source is pool 0 zvol 00, the plan is okay. Then on the destination, of course the plan is okay for my demonstration because it's nice. After 10 minutes I will see how retention working and so on. But for production you can use the default plan or the longer plan, at least let's say 1 month. So destination, it's also pool, in this case is pool 1, zvol also 00. And we have also some options like dedup, mbuffer, mbuffer to buffer the data, backup data. So now the task has been created, so I can just put the set, and in the set you will see that we have a source and we have a destination, right? And that's the retention plan. If I do not put the retention plan on the destination, the default source plan is taken. So the source and destination will have exactly the same retention plan. It don't need to be identical. On the destination we can put a different plan. So now when we switch back, so here we have already 3 snapshots, and on the destination there is no snapshot yet, but we can expect very soon. So here there is also the status command, which is showing the last status of the task, running task or tasks. You can have also more tasks. Okay, so now on the pool 1 you see there is a plus sign already, means the first snapshot was already replicated to the pool, and now every minute, because we have set every minute a new snapshot will be created, and every minute all the deltas between snapshot will be automatically replicated. With the new version, which I'm showing here, there are also commands for VMware ESX. Okay, so the ESX commands like ESX register, unregister, and the attached data stores are here. So the consistent backup of the, let's say, Exchange or MS SQL can be made, and you can backup your virtual machines with your operating system and your databases like MS Exchange or MS SQL or others, and all your other applications and all your data in the consistent way. Okay, so this is really very high value and quality inside, because you can store the data and you can protect the data for the disaster recovery, and the disaster recovery will be just mounting a clone from the snapshots. So when you click on clone, then you can clone, and anytime you can have an instant clone. And you can attach to the target later, because there is no target created yet on the pool 1. Okay, so later you can create the target and attach this clone to the target, right? So I can create a new target, let's say 250 clone, and select this available clone. And this clone can be attached to your system. Or we can also go to the iSCSI target, refresh. After refreshing, we have the clone. Okay, this clone is not connected yet. So now the clone is connected. And when we go to disk manager, then we see the disk E, and when we go to disk E, then we see exactly the same stuff which was here, because this is exactly the clone. So on the disk D, we have such data. On the disk E, we have this data. Okay, exactly the same. Okay, if you don't need this anymore, then you can, because you backup, then you can go and disconnect, and later you can delete this clone, and next time you can again create a new clone from a new snapshot, for example. Right? So that is how it is working. It is very easy. Same way it works when you will be connecting with VMware ESX. Okay, so there is also option to create the shares. So when you go to dataset, you can now say volume, and then okay, you can say sync always. If you want everything sync, you can sync disable. You can enable quota, because this is a not a block device, but this will be file system. So now in the volume I can add a share. So I can say NFS, for example, as my share name, enable NFS protocol, yes, apply, and I have already NFS share called NFS available in my network. So I can go to data browser 192.168.0.250 or 251, doesn't matter, and that's my NFS share. Okay, so you can create new folder and copy some data inside. So it is very easy to use, and the next version which we are preparing will have also Samba SMB next week, or even end of this week. The version will be ready for evaluation. But at this time we are with iSCSI and NFS. Again, I will run the scrap. When I run the scrap, now there is some data, so it is already reading all the data. You have scheduler, of course, for the scrap. You can select, let's say, every month, somewhere in the night, early morning, apply. So now every month the system will automatically read the data, checking for the errors. Okay, in diagnostics you can see how memory is used in your system, and you have logs. If you download all, then you have all the information about the system. Also during downloading the logs, some important benchmarking or some important diagnostic programs are started, so you have results of this inside. And in system settings, once everything is already done, system settings is done, you can again save the settings, and you can download again the settings to your disk. If you will need, let's say, reinstall Jovian new from scratch, because let's say your boot media was destroyed, so you can just reinstall new from scratch and later restore the settings. Okay, that's I guess and everything what we were planning for today. So we have cache explained, we have target, we have created the storage. That's all. We have also shown how to make the clone, how to make the auto snapshot, how to even back up the data to another pool. In case of backing data to another Jovian, you just switch the command and enter the destination IP as well. Here you see that we have a destination, and we will put IP in these examples, right? So we are done for today. I would like to say thank you very much for joining us, and if you will have some questions regarding the evaluation, just don't hesitate to contact me or my colleagues. Thank you very much, and bye.